Does Planet 9 really exist? This is a question that has been asked time and time again by scientists, theorists, and astronomers. The search for a planet beyond Neptune has been going on for more than 2 decades since the discovery of Pluto. To find proof of a ninth planet, astronomers have examined the farthest limits of our solar system for decades. In this video, we will dive into the concept of Planet 9, explore the evidence behind its potential existence, and examine why it is so difficult to prove definitively if it does or does not exist. Stay till the end of this to get a better understanding of this mysterious celestial body. In January 2015, Caltech astronomers Konstantin Batyin and Mike Brown presented new evidence of a huge planet in the outer solar system that follows an unusually extended orbit. Instead of actual observation, the prediction is based on intricate mathematical modeling and computer simulations. Please give this video a thumbs up and subscribe to this channel for more videos before we proceed. Click the bell icon to receive notifications of new videos. Have you already done this? Let us start. According to Jim Green, head of NASA's Planetary Science Division, the idea of a new planet is undoubtedly an exciting one for me as a planetary scientist and for all of us. But this isn't the identification or finding of a brand new planet. It is still too early to declare for sure whether or not there is a Planet X. What we're witnessing is an early forecast derived from a small number of observations. It's the beginning of a procedure that might provide an interesting outcome. According to Caltech researchers, Planet X may have a mass of around 10 times that of Earth and a size between Uranus and Neptune. The estimated orbit is, on average, nearly 20 times further from our Sun than Neptune, which orbits the Sun at an average distance of 2.8 billion miles. One entire circle of the Sun would take this new planet between 10,000 and 20,000 years to complete, where Neptune completes an orbit roughly every 165 years. After the 1846 discovery of Neptune, there was widespread conjecture that another planet might exist beyond its orbit. The most well-known of these hypotheses suggested the existence of a far-off planet that affected Uranus and Neptune's orbits. Percival Lowell made detailed calculations to determine the orbit and location of the fictitious trans-Neptunian planet. And in 1906, he started a comprehensive hunt for it. He gave the imaginary object the moniker Planet X, which Gabriel Dallet had already used. After continuing Lowell's search, Clyde Tombaugh found Pluto in 1930, but it was quickly judged that it was too tiny to count as Lowell's Planet X. The discrepancy between Uranus's projected and observed orbit was found to have been caused by the use of a previously incorrect mass for Neptune after Voyager 2's flyby of Neptune in 1989. Before the discovery of Pluto, efforts were made to identify planets beyond Neptune using techniques like orbital perturbation indirectly. George Forbes, who proposed the possibility of 2 trans-Neptunian worlds in 1880, was one of the pioneers. One would be 100 astronomical units, AU, from the Sun on average, which is 100 times farther than the Earth is from the Sun. The semi-major axis of the second would be 300 AU, and that the planets would be responsible for a clustering of orbits of many objects. In this case, the clustering of the aphelion distances of periodic comets at 100 and 300 AU, his study is compared to more contemporary Planet 9 hypotheses. This resembles how comets from Jupiter's family aphelion distances congregate close to its orbit. Sedna's odd orbit was discovered in 2004, which sparked conjecture that it had come into contact with a large body other than a planet. With a detached orbit and a perihelion distance of 76 AU, Sedna cannot have formed its orbit due to gravitational interactions with Neptune. According to several authors, Sedna entered this orbit by colliding with a large object such as an undiscovered planet in a far-off orbit, a star that later traveled close to the solar system, or a member of the open cluster that formed with the Sun. The discovery of a second sednoid in a close orbit with a perihelion distance of 80 AU in March 2014 sparked new claims that a super-Earth still existed in the far reaches of the solar system. Planet 9. The hypothetical Planet 9, often known as Planet X, is a large object in an elliptical orbit beyond Pluto that would require 10,000 and 20,000 Earth years to complete one circle of the Sun. Planet 9, as a potential ninth planet in the solar system's outermost region, is known as Planet 9. Extreme trans-Neptunian objects, ETNOs, which orbit the Sun at average distances greater than 250 times that of the Earth, have an odd clustering of orbits that its gravitational forces may cause. These ETNOs orbits are inclined and frequently make their closest encounters with the Sun in a single sector. These alignments imply that a planet has not been found and may be guiding the orbits of the farthest known solar system's objects. However, other astronomers contest this finding and claim that the orbital grouping of the ETNOs is the product of observational biases brought on by challenges associated with finding and observing these objects during much of the year. Radius and mass of Planet 9. Planet 9 has a radius of 2 to 4 times that of Earth and a mass of 5 to 10 times that of Earth. According to Brown, if Planet 9 exists, its mass would be sufficient to clear the orbit of massive bodies in 4.5 billion years, the age of the solar system, and its gravitational pull would be strong enough to make it a planet by the standards of today. According to his statement, Planet 9 meets astronomer Jean-Luc Margot's requirements and would be recognized as a planet if and when it is discovered. What evidence do we have about this planet? The gravitational attraction of Planet 9 on other bodies is proof of it. The planet's gravity will impact the orbits of other planets if it is accurate. Hence, use some algebra to identify the source if anything seems to pull on a planet. When John Couch, Adams, and Urbain Le Verrier independently observed that Uranus appeared to be being pulled by an invisible planet, this is how Neptune was discovered. We do not have any gravitational pull on Planet 9 in this situation. We observe a peculiar collection of little icy bodies called Kuiper Belt objects in the outer solar system, KBOs. You would anticipate that these orbits of KBOs would be randomly orientated inside the solar system's orbital plane if there were no planets beyond the Kuiper Belt. Instead, we observe that many KBO orbits are grouped and share the same orientation. Although it is unlikely, this may be just the result of a chance. How may Planet 9 appear? The mass of Planet 9 would most likely be a magnitude approximately 10 times bigger than Earth's, with a diameter approaching that one of our ice giants, assuming that this planet-like object exists in space. The body's origins were likely somewhere between the orbits of Jupiter and Neptune, with a birth very similar to any of the other gas planets in our solar system, according to a possible explanation for the body's remote location. Before it could stuff itself, Planet 9 would have been jolted by one of the two gas giants' gravity wells and would have ended up in the freezing wastes. Despite its huge, slow orbit, enough time ought to have elapsed since the solar system's formation for it to have cleared its orbit of iced fragments of rock and dust, giving this stunted gas ball an official planetary designation. Another less plausible possibility is that Planet 9 is an adopted child kidnapped from a different passing star long ago. Today's video has come to an end. Remember to give this video a thumbs up and subscribe to the channel to view more content. Remember to click the bell symbol to receive notifications when new videos are posted. I will leave you with this and hope to see you in the next video.